More than half of the matter in our universe has so far remained hidden from us. However, astrophysicists had a hunch where it might be, in so-called filaments, unfathomably large thread-like structures of hot gas that surround and connect galaxies and galaxy clusters. A team led by the University of Bonn, Germany, has now for the first time observed a gas filament with a length of 50 million light-years. Its structure is strikingly similar to the predictions of computer simulations. The observation therefore also confirms our ideas about the origin and evolution of our universe. The results are published in the journal Astronomy Astrophysics. We owe our existence to a tiny aberration. Pretty much exactly 13.8 billion years ago, the Big Bang occurred. It is the beginning of space and time, but also of all matter that makes up our universe today. Although it was initially concentrated at one point, it expanded at breakneck speed, a gigantic gas cloud in which matter was almost uniformly distributed. Almost, but not completely. In some parts the cloud was a bit denser than in others. And for this reason alone there are planets, stars and galaxies today. This is because the denser areas exerted slightly higher gravitational forces, which drew the gas from their surroundings towards them. More and more matter therefore concentrated at these regions over time. The space between them, however, became emptier and emptier. Over the course of a good 13 billion years, a kind of sponge structure developed. Large holes, without any matter, with areas in between where thousands of galaxies are gathered in a small space, so-called galaxy clusters. Fine web of gas threads. If it really happened that way, the galaxies and clusters should still be connected by remnants of this gas, like the gossamer thin threads of a spider web. According to calculations, more than half of all baryonic matter in our universe is contained in these filaments. This is the form of matter of which stars and planets are composed, as are we ourselves, explains Professor Dr. Thomas Rieprich from the Argelander Institute for Astronomy at the Univ. Yet it has so far escaped our gaze. Due to the enormous expansion of the filaments, the matter in them is extremely diluted. It contains just 10 particles per cubic meter, which is much less than the best vacuum we can create on Earth. However, with a new measuring instrument, the Rosetta Space Telescope, Rieprich and his colleagues were now able to make the gas fully visible for the first time. Rosetta has very sensitive detectors for the type of X-ray radiation that emanates from the gas in filaments, explains Rieprich. It also has a large field of view. Like a wide-angle lens, it captures a relatively large part of the sky in a single measurement and at a very high resolution. This allows detailed images of such huge objects as filaments to be taken in a comparatively short time. Confirmation of the Standard Model. In their study, the researchers examined a celestial object called Abell 3391/95. This is a system of 3 galaxy clusters, which is about 700 million light-years away from us. The Rosetta images show not only the clusters and numerous individual galaxies, but also the gas filaments connecting these structures. The entire filament is 50 million light-years long. But it may be even more enormous. The scientists assume that the images only show a section. We compared our observations with the results of a simulation that reconstructs the evolution of the universe, explains Rieprich. The Rosetta images are strikingly similar to computer-generated graphics. This suggests that the widely accepted Standard Model for the evolution of the universe is correct. Most importantly, the data show that the missing matter is probably actually hidden in the filaments. Story source: materials provided by University of Bonn. Note: content may be edited for style and length. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.